at direct variation. Direct variation. It's an application of linear equation. Direct variation, where two things are related in such a way that the ratio of their values always remains the same. The two variables are said to be in a direct variation. And a direct variation equations, they look like y equals kx. K represents a number. So it's a number I don't know. And we call that, has a special name, the constant of variation. Okay. Constant of variation. So just looking at this on its own here, this represents some number in here, and it's a placeholder for a number. What do I know about this equation when I graph it? What will it look like when I graph it? What do you think, Annie?
It will go across the origin.
It will go across the origin. Why do you say that? What do we call that number that we usually see here? Plus b. So what are you getting at here? So what's k like? So this looks a lot like y equals mx plus b, where b equals 0, okay? And m and k really mean the same thing. M is slope. In direct variation, we call it a constant of variation, but they're the same thing. Constant of variation is the slope of a line. So it is. It looks like a line when you graph it. But what is it like when you're actually applying it somehow? So we're going to look at this example here. So suppose an object on Earth weighs 150 pounds. On Neptune, the same object would weigh 165 pounds. So what do I do? How do I get from 150 to 165 pounds? We have to multiply 150 by some number. How do I kind of figure out what that number is? So 150, right, times some number gives me 165. So let's call that number, I'm going to call it, I'm just going to call it a question mark. So how do I figure out what that is? The what? Does subtracting help me? Yeah, because I'm multiplying, so you have to do the opposite. So if you were to do this, who has a calculator? What's 165 divided by 150? And I will go to a decimal point. 1.1. So we multiply a weight on Earth by 1.1. So if something weighs 100 pounds on Earth, what's it going to weigh on Neptune? What? 110. You're right. So can I do that for any weight? What if it's 50 pounds on Earth? 55. So you multiply by this number. This number is now a constant, right? So we're using this constant of variation is like that 1.1. What do you multiply something by to kind of make a conversion like that? Okay, we did this. What would it be if it's 200 pounds on Earth? 200 times 1.1 is 220. Okay, so that's the constant of variation, that 1.1. Where you take whatever value it is, you multiply by this, and you can kind of do a conversion in this case. That's a direct variation. So we're going to compare this. We did this actually in our little opening here. We compare y equals kx with y equals mx plus b. What is the slope here? M and k are the same. So if I want to graph these things, I just graph them the same way that I would graph any y equals mx plus b. What's the slope of this guy? What's the y-intercept? 0. So I think it was Danny made that observation. It's going to go through 0. This is 3 over 1. So I go up 3, right 1. Now I'm running out of space. I can also go down and left. Down 3, left 1. So here's an example of what a direct variation looks like when you graph it. It's a line that goes through 0, the origin. How do you know if you have a direct variation? So given a linear equation, how do you know? You're always going to compare it to y equals kx. So may have to put it in this slope-intercept form, because that's what this is. So for example, if you have y equals 4x plus 2, what's b? Is this a direct variation? Because what has to be true for a direct variation?
B has to be 0.
So this is not a direct variation, so there is no k. I'm putting a not applicable here. If it's not a direct variation, there is no constant of variation. Alright? How about this one now? Is it going to be a direct variation? I don't want the answer, I want tell me what I need to do. What do I need to do? I don't want the answer. How do I do this? Put it in function form. How do I do that now? Alright, negative 3x equals negative 2x. Oops, negative 3y, rather, sorry. And then what? Everything gets divided by negative 3. That becomes my big 1. Negative 2 over negative 3. Okay, so here we are in function form. What is the b of this one? 0. So is this a direct variation? What is the constant of variation here? 2/3. It's like asking what's the slope. It's the same question. Slope and a constant of variation are the same thing. So if you want to know if something's a direct variation, put it in y equal form. If you have something that looks like y equals mx plus b and b is 0, then it is a direct variation and the constant of variation is slope. So let's try this guy here. How can I tell if this is a direct variation? I'm on the bottom of the page, because you're following along here. So I have to put it in y equal form. I'm going to add that x to both sides. What's my y-intercept? No? Look at the equation. What's the y-intercept? 1. Okay, yeah, I heard all kinds of crazy, so I just want to make sure we know what it is. Y equals 1. Is this a direct variation?
No. Nope.
Why not?
It's not,
It has to go through the origin. It's not a direct variation. Let's try this one. We have to solve it for y. We're going to subtract 4x. And then I'm going to divide both sides by that negative 5. So I get y equals, what's negative over negative? Positive. Is this a direct variation? How can I tell? Yeah, does it look like y equals kx? Is the y-intercept 0? Yes. So this is a direct variation. What is the constant of variation? 4/5. That's it. That's all there is to it. Don't make it harder than it is. Yeah. Huh? Because it depends what the question is, right? The question I'm asking here, is this a direct variation? And if it is, what's the constant of variation? So to find out, solve it for y, which I did. I know it's a direct variation because the y-intercept is 0, and it's linear, and m and k are the same thing. The constant of variation is 4. That's it. Make sense? Yes, question?
When you're writing it, would you put k or
Running what?
like when you're writing it?
K is like m, right? It's the number in front of the x. It's like, think of that 1.1. It's I think you multiply by. So it's just a number. Yeah.
Is your test for test rules so it's not applicable?
When did there not be a K?
When there's no direct variation.
Well, you can have a K. Well, oh, like here, yeah. It's like I did right here. It's not a direct variation. Do exactly what I did right here. Okay? What? 1? And why they did K? What? What do you mean? I don't know. That's what they call it. Why they call it M? All right. Find the constant of variation. Goodness gracious here. So here is, come back here. They're giving you a graph and they're saying, first of all, is this a direct variation? Just looking at the graph.
Yes.
How can I tell it is a direct variation? How can I tell?
1 through 0.
It's a line that goes through 0. Any line that goes through 0 is a direct variation. Now, what is that constant of variation?
Negative 1.5.
How how'd you get that? Why are you already getting negative 1/2?
Because of
What'd you do? Why are you putting x over y? That's basically what you did, right? I don't know. Isn't that how you got negative? I don't know how you got negative 1/2. Remember how this is the same as slope?
Yeah.
How do you find the slope of this line?
Go up to
Well, it comes, so you're starting here, or where are you starting? Which point? This one or this
0.
one? Start at 0? So my change in y is I go up 2,
Up to the left.
and then I go left, which is the negative direction, correct?
Yeah.
And can I reduce this?
Yeah. To negative.
So what's my k? Negative 2, because k and m are the same thing. If you can find the slope, you have it. Other ways to do this is, you know y equals kx. I've got a point here. So here's an x, here's a y. Plug that in. So if my point I'm using is negative 1, 2, substitute it in. So y is 2, k is negative 1. Solve this for k by dividing both sides by negative 1. So k is negative 2. This is a silly way to do it. I'll say that. There's no reason I really have to do it for this. If you have a point, let me see, I think that's on the next chart here. Method 2 is basically solving y equals kx for k. Remember our literal equations. How do I solve this for k? Divide by x, right? K is y over x. Okay, that's what I was doing here. If y equals kx, then k is y over x. Here's an x, here's a y. So we just kind of plug in there. It is much easier. What am I saying? Put the 2 here, put the negative 1 there. So it's always y over x, y over x. How about the slope formula? Because 0, 0 is always going to be a point on direct variation, right? Let's do a general form. For any direct variation, 0, 0 is a point, and x, y is another point. I don't know it yet. It's any direct variation. What's the slope formula? What's the slope formula? We all need to know that. Slope formula is y2 minus y1. So if these are my y2s and my y1, so can I say y minus 0 over x minus 0? What's y minus 0? X minus 0. Exactly. Good. So if you know you have a direct variation, and you know what one of the points is, y over x will give you the constant of variation. Y over x. So how do I tell if something is a direct variation? I give you a table. So I'm looking for this one on here. I don't have it on here. So we're just going to look at this example. How do I know? By looking at points. So what you do is you basically say, does it have the same constant of variation? You find the constant of variation by doing y over x. Y over x, 30 over 10. Let's reduce that. What do you get? Y over x is 15 over 5. Y over x is 3. I'm getting the same constant of variation. In a direct variation, it's always that same number. So, is this a direct variation? Yes. What about this one? You look and say, what's k? Y over x. 5 over 15, 1/3. Y over x is 26 over 3. Whatever that is that 1/3? This one is not a direct variation. If you're not getting the same k every time. So the constant of variation, the y over x, must be the same for all points. Okay? If it's a direct variation, I also want to know what is the equation. This is a direct variation equation, y equals kx. Do I know what k is for this one?
Yes.
What's k? So what's the equation? This is a direct variation equation. You see a y, you see an x, and you have the k filled in with a number. This one. This is kind of important because we tend to mess this up. So let's see, I think I've got some more examples here. Okay, These are you tries, let's just do them because I think this might have been a little confusing. Okay, so y equals 2x, is this a direct variation?
Yeah.
How do you know?
There's no number.
There's no, what do you mean no number?
There's
No
no
y.
y, there's no y
What is the
axis.
value of the y-intercept?
0.
0. V is 0. So can I graph this guy?
Yes.
Start at 0, what's the slope? 2 or 2 over 1 so that I can graph it. Up to right one, up to right one, up to, can't go there. I can also go down and left. This one's on your paper, isn't it? You should be doing this with me. Down to left one. And then this is a graph of the direct variation. Okay, so it's just graphing. Now this one is an interesting question. So the graph of a direct variation passes through point 4, 6. You can kind of envision what this looks like. I know another point is always 0, 0, and there's another one at 4, 6. And it's a direct variation, so it's this one. Write a direct variation equation and find the value of y when x is 24. So it's two parts. First, let's find the direct variation equation. This is a direct variation equation, y equals kx. So basically, all I have to do is find the value of k and plug it in. How can I find the value of k if I know one of the points is 4, 6? If y is kx, solve for k. So k equals y over x. Do I have a y in the next value?
Yes.
What's y? Here's my point.
6.
And then what's x?
1.
Reduce. Oh, do you have to reduce it? Always. 3 over 2. What's k? 3 over 2. What's my equation?
Y equals.
Yeah. That's it. So think about all you had to do. All you had to do was find k by saying it's 6 over 4 and reduce that to 3 halves and plug that in. That's it. That's it. Oh, I didn't finish question 1. Look at me how bad I am. I didn't notice this. What's the constant of variation for this one? Did I finish number 2? What else have to do with 2? Oh, you're right. Oh, all right, I'm having a bad day, aren't I? Let's finish number 1 and then we'll finish number 2. What's the constant of variation on number 1?
2.
What is its slope?
2.
They are the same. Now we're getting back to this one. Okay, thank you, Noah. Here is the direct variation equation. The second part is find the value of y when x is 24. How do I do that? Yeah, it's a substitution. So that's y equals 3 halves times 24. I'm going to cross reduce that to 12. So y equals 3 times 12, which is 36. So I have another point, 24, comma, 36, don't I? Because when x is 24, y is 36. A little test. What should I get if I do y over x? 3 halves. Do I? That's 36 over 24. Adds a common factor 12, doesn't it? 36 divided by 12. 24 divided by, there we go. Right, it should always work that way. Y over x are going to be the same for all of them. Okay, I think I answered all the bits for 1 and 2, did I? Okay. What do I do here? A, B, and 3. Perfect. Okay, is this a direct variation?
Yes.
How can I tell? How do I know? See if it has the same k. K is y over x. Well, let's see, this is 25 over 10. Let me reduce that. Divide by 5. Divide by 5. So the k for this pair of points is 5 over 2. What about y over x being 15 over 6? I see a 3. Divide by 3. Okay, looking promising. 10 over 4. Well, that's also 5 over 2. And this one, y over x, 5 over 2. I got 5 over 2 each time I tried to find k by using y over x. So is this a direct this is what I want when I ask you for an equation. This is not what I want. You have to do this. The equation has x's and y's in it, and you filled in the number for k. Alrighty? Maybe? There are word problems that we do with this, because that's a word problem. Life is a word problem. Yeah, it is. This one's easy? The number s, we're using a variable s to represent the number of tablespoons of sea salt needed in a saltwater fish tank. Okay, so I don't know anything about saltwater fish tanks. But it says here that the number of tablespoons of sea salt varies directly with the number of gallons in the tank, and we're using W to represent that. A pet shop owner recommends adding 100 tablespoons of sea salt to a 20-gallon tank.
A lot of salt.
Now, it's a big tank, right? So how do I write a direct variation equation to relate W and S? And let me show you how you do this, because it's easy, once you kind of see it. I always look for the important things. Something varies directly with something else. And the way we write something varies directly with something else is we say that thing varies directly, put an equal K, with something else. So salt varies directly with water. The amount of salt varies directly with water. So when we see the words vary directly, put the equal K in. S equals KW. Now my job is to find K's value so I can get the rest of this equation. Now they will give you an example of this. So let's see, 100 tablespoons of salt. So when S is 100, what's W? 20. So what I can do now is two things. I can solve this for K, and I get K equals S over W. How do I get that? Divide. Divide both sides by W. So if K is S over W, let me write it over here. What is that? 100 over 20. That goes away, that's a 5, right? My constant of variation is 5. So let's go back to our original equation. If S equals KW and K is 5, how can I write this equation? S equals, yeah?
S equals 5W.
This is the equation. This is an S, the other one's a 5. I know that's a little hard to tell. So salt equals 5 times the amount of water. That's what we're figuring out here. So once I have this, it's going to say how many tablespoons of salt should be added to a 30-gallon tank. Well, I know the equation, S equals 5W. Now, is this 30 gallons? Is that an S or a W?
W.
That's a W. So I'm going to replace that in here. And then what do I get? 150 watts tablespoons of sea salt.
I knew it.
Well, that hurts. Okay? So let's review what the steps are. The basic steps are read the question, look for those words very directly, and set that up. S equals KW. Very directly like equals K. They're going to give you an S and a W. Use that S and W to find what K is, substitute it back in. Now you've got an equation that works for any of them. They're either going to give you an amount of water or they're going to give you an amount of salt. Let's say they say you have 200 tablespoons of salt, and you want to know, you want to use it all. So how big a fish tank do you need to use it all? So how do you do that? Oh, where is this the S or the W? I've got an equation. So that says 200 equals 5W divided by 40. Yeah, what do you get? 40. 40 what? Okay. So you can go either way once you have that equation. Let's try another example here. What's the pattern? You know what? I'll let you a little secret. Do you remember proportions? This is proportions. It's just thought of, you're thinking about it a different way. You may see something, a word problem that says something is directly proportional to something else. That's direct variation. Do it just like it's direct variation. Same thing. Okay. I don't know if you still even do this anymore. You still download music?
Yes.
Yeah, I totally still do that. No?
What? You don't
Okay,
download music?
well, in the old days, iTunes was kind of it. So, I want to download songs from the internet. So the cost of downloading songs is shown at the right. So if you download 3 songs, it costs $2.97. If you download 5, it costs $4.95. If you download 7, it costs $6.93. Is the number of songs and the number of C, is that a direct variation? Well, how can I figure that out? What do you do with this, Connor? Divide what? C over S. C over S. Who's got a calculator? 297 divided by 3. Divide, right? We're going to divide. Wait 1 second. All right, 495 divided by 5. 693 divided by 7. Is this a direct variation? What is K? 0.99. So C varies directly. There's my equal K with S. And K is 0.99. So I just plug that in. So here we go. Cost is 0.99 times the number of songs. I have rough answer to this question. So if I wanted to download 10 songs, what would the cost be? What would the cost be? I want to know a number, an amount, a dollar amount. Thank you. Okay. You get a gift certificate for $20. Somebody gives you a gift certificate for $20. How many songs can you download?
15.
Cost.
Yeah, 20.
Right?
20.
Right? Well, what's 20 divided by 0.99? What is it?
19.19.
What is it?
19.
What is it?
19.8.
Is that right?
No.
Again, I calculated right there. What is it?
Wait,
That guessing.
20.
Yeah, 19.8.
20 this. 20.2. Guys, 20
A
songs.
little more than 20. What is it?
Fine, I thought about that.
20.2.
Oh, 2?
Yeah.
So, well, how many songs can I download? 19.2 of a song? No. So you can get 20 songs. Yes. Yes, sir.
You can't get like 2 seconds of a song, okay?
You can.
How would you explain it? Why does it, excuse me, stop talking. He had an excellent question. He said, it says explain. So why does C vary directly with S? How would you explain that? I'm so glad you asked that. Why? Why? Why is that? Why do you say yes? There's the slope. What is the other name for it when we're talking about direct variation? The K or the constant of variation is the same for all the points. If your constant of variation, your y over x, in this case c over s, is the same, then you have a direct variation. Great question. Okay, so here's my summary. Direct variation, y equals kx, k stands for constant of variation. The constant of variation is k equals y over x. You can rediscover that just by solving y equals kx for k. Divide both sides by x, you get this. So if you have 2 points, or you have 8 points, and you know it's a direct variation, 2 comma 3 is a point on a direct variation. What's k? What is its value in this situation? K equals y over x, so what's k? K equals y over x. Just like slope, y over x. 3 over 2. What would the direct variation equation be? Okay, this is the direct variation equation. It has a y in it, it has an x in it. This is not a direct variation equation here. This is just the value of k. When I ask for, and I'm saying this many times because people get this wrong. So make a note of this. A direct variation equation looks like this. It has a y, it has an x, and it has a filled-in value for k. You graph these the same way that you graph anything except your v is always going to be through the origin. And then use k as your slope to go up and over. Okay? Summary, that's it. Are there questions? Because I have a feeling I think we got a book here. Questions?